Arc welding is a process that is commonly used to join metal together. Arc welding was first developed in the late 1800s, and it has been widely used ever since. Today, there are many different methods of performing arc welding, and the applications for arc welding are almost too numerous and too widespread to count. Learning about arc welding is an important step in becoming proficient in working with metal, and will help establish a solid foundation for you to build on as you gain knowledge and experience as a welder. In this part, we're going to discuss the basic concepts of arc welding. To do that, let's start by talking about welding in general. Welding is one of several ways of joining metal pieces. During welding, the metal pieces to be joined are subjected to heat, pressure, or both in order to bond them together. Two common welding processes are oxy-fuel or gas welding and arc welding. Arc welding is the process of joining two pieces of metal by using an electric current to help create the heat that is needed to melt the metal pieces that are to be joined. The current used in arc welding is produced by a welding machine. The current flows through an air gap between the welding machine's electrode and the metal that is being welded. The air gap has a high resistance, and current flow through the air gap creates an arc which generates an intense heat. This heat melts the edges of the metal pieces, as well as any metal that is being added to the joint. Everything in the weld zone, the electrode, the arc, and the molten metal, which is often called the weld pool, is protected from contamination, usually by a gas shield. After the metal cools, the area of the weld forms a bond between the two pieces of metal. There are many methods of performing arc welding, including shielded metal arc welding, gas tungsten arc welding, gas metal arc welding, submerged arc welding, and flux core arc welding. Originally, arc welding was performed manually. Manual welding involves hand control of the welding arc and any filler metal that's being added to the weld. One example of a manual arc welding method is shielded metal arc welding. The arc is controlled by hand, and the electrode is short and needs to be replaced often. Semi-automatic welding involves some aspects of the process being automated. For example, gas metal arc welding is sometimes performed semi-automatically. That's because the electrode wire is fed off of a reel. Because the electrode wire is fed off of a reel, interruptions for replacing electrode wire are radically decreased. Automatic welding features automatic control of the arc and any filler metals. Microprocessor controllers are used to store the information needed to automate the welding process and to execute the welding program. Automated welding yields precision, economy, and repeatability that is hard to match with manual and semi-automatic processes. Three welding methods that are often automated are submerged arc welding, gas metal arc welding, and flux core arc welding. Automated welding is often used in high-volume work, where the cost of the extensive equipment setup is justified by the resulting increase in production. Robots can also be used for welding to help meet the increasing needs for productivity and quality. Robots can be justified in situations where many parts or assemblies need to be welded on a full-time basis every working day.